Hello, my name is Jake Ford and I'm a gameplay programmer. One of the first projects I'm going to show you is Miscreant Mash, which is one of the more recent Unity projects I've been working on. It was done in conjunction with a team of other students. I was one of two programmers that worked on it. My focus for programming in this game was primarily the combat system for the enemy AI, player AI, and how you reference moves and the monster stats. The other programmer focused on UI stuff such as buttons, navigating between them, having level transitions, that sort of thing. The monsters are done somewhat simply. The both the monsters themselves and the moves are held on two scripts. The monsters on a script which mostly just holds a dictionary, which is a string and a float array, where the string is the reference of the monsters' names, and the float array is the stats for each of the monsters. The moves are held in two dictionaries. One is a string interarray dictionary where the move names are the reference key and the move stats are an interarray. The stats are mostly straightforward: accuracy, damage, health, and the like. The one of the integers is basically a reference key which describes what side effects the move will have and refers to which side effects the move will have. The second dictionary is a string int array dictionary where the monster's names are the reference key and the names of the monster's moves are held in the string array. So if I go into combat here, at the beginning of the combat start, the game pauses for several seconds as it waits for dictionaries to be formed and for references to be made. The One of the first things it does is it takes the names of the monsters which we decided on the last screen. I just went with the defaults, and it uses that name to reference the monster stats, pulls them in and sets how much health, how much speed, how much attack power the monster should have at base, and it pulls from the move dictionary what the different um, the names of the different moves it should have at its available. The other dictionary for moves is only called when you actually trigger one of these moves. So if I do Inkshot, which as you can see in the top left, attacks several times with each hit having a 50% chance to hit, it will do some damage. Then the enemy attacks with White Wine, which is a move which does a small amount of damage and decreases our attack power. So if we attack with Inkshot again, we can just miss each time. That's also fine. But we would have done less damage had we actually managed to land a blow. The combat system is fairly simple from a AI point of view. The enemy AI doesn't really think too much about what it's doing, since I had a lot to do just doing all the references for the moves, coming up with programming how to do all the different side effects, running the turn order and the likes. So it mostly just does have checks to go like, does this move still have power points with which to do the move? If not, try and choose again. There isn't too much to the MI. It's mostly just roll an umber and say it's do this move. Specifically, it goes through each of the moves, checking if they do have power points with which to go, and if they do have power points, then it sort of stores them for further check, and then it chooses from the ones that do well reported to do have PowerPoints left. It takes those and just does a random number generation, choosing them with between them with equal odds. The second project I want to showcase today is Messy Memories, which was another project I did for school. I was on a group of several students with two coders total, including myself. I made several scripts for this project, such as the projectile script for these platforms, where you launch them with some force for several seconds. They go for about 1 second at a set amount of force, and then they stop and lose their rigid body, so they stay in place. It's one key to send them out and one key to pick them up. Both sending them out and picking them up uses a raycast. The one for sending them out is rather short, just to make sure that they do actually manage to spawn without being stopped immediately. And the other raycast to pick them up is slightly longer because it's just you picking them up. A second script I made was a grappling hook point for this, where you look at one of these grappling points, you click the Q button, and it grapples you in. It turns off your ability to move yourself so that you don't screw up the momentum you have and just end up jumping up and down, bouncing up and down slowly underneath them. Instead, it allows you to, by gravity, have a smooth arc underneath them, as all it does is continuous. Whenever you go too far away from it, it applies force in towards the direction of the grappling point, using the spring formula as a basis for the script there. The last project I want to show for today is called Nightly Night Adventures, and it is a Pac-Man reskin that I did for class with a couple classmates quite a while ago. I was the sole coder for the project, so I was responsible for controlling the player, picking up the dots and points, and doing level transitions, as well as AI control. The AI is as close to Pac-Man as I could handle at the time. The travels back, it bounces back and forth between a chase state and a scatter state repeatedly over time, and during the states, the behaviors are based off of how they would have done in the original Pac-Man, where the red ghost goes directly for the player. The orange ghost tries to get near the player and by setting them as the target until they're close. And whenever they are, when they do get close, then they try to go back to their corner. The rest of the time, the decision making is done based off of they go to these intersections, which is marked by where the red arrows are, and they do quick raycasts to check for walls, and then they tend to do a distance check between them, each location in the wall, each raycast that didn't run into a wall, and where their target is, and whichever one is closest to their target, based off a distance check, is where they try and go.